Hi there, it's Lester Martin from Hortonworks University, and we're going to continue on in our demo series of our Essentials one-day course offering. We've been tracking these notes on these demonstrations on this GitHub project you see listed here in the video, and we have made it all the way down to risk analysis with Pig. So I'll click onto that, and basically, there's our goal. We're going to create a Pig script that leverages some information we already have in the system. So specifically, we'll focus down here on the geolocation table that we created in the Hive demonstration. We'll build a quick driver mileage table, and then based on those two tables, we'll write a Pig script that calculates a risk factor for drivers. So that's what we'll focus on. So to get started, let's go ahead and create that initial driver mileage table. And as you see right here on the left, scrolling to the top is in fact what we need to run. It's a CTAS as we described earlier. So I'm logged into Embari as Maria. I'm going to go over to, in this case, quickly to the Hive view just to create that table. I'm just going to go ahead and paste that in short and sweet. We'll execute that. That might take a minute to run, so I'm going to hold on a second here. And while that's executing, as we see kind of down here, the test session, etc., we actually want to store, we're ultimately going to create this risk factor table that we'll load into. So we'll go ahead and create that information, that table definition. Run that in a separate window while that's running. Looks like that finished. We'll just kick another worksheet up. And as you see here, we're really going to store the individual drivers identifiers, the counts of how many events, this is risky events we are focused on, how many miles they completely did, and then what's their risk factor based on those elements. So I'll run that as well. That should just take a moment to finish. And I think our other CTAS table creation has finished. And I'll just 1 second. And now that that's finished, I'll just refresh and make sure the default database we in fact have our driver mileage table. There it is right there. And then our risk factor table. So we could do a quick look. Risk factor should be empty. So we'll do a quick select 100. Nothing available to us here. And in another window, I'll also kick off the driver mileage record as well. So it looks like those finished. As we expected, the risk factor is empty, and the driver mileage is, there we go, the information that we see. So now we'll go ahead and navigate over to Pig, where we're going to focus on for the rest of this demonstration. And if you scroll through this, you'll see what we're doing here. We'll build the script, save it, and then we'll walk you through each one of these steps. I'll just type those as we go along to help us see that in the background. So in the Pig world, we'll just create a new script, and we'll go ahead and save it. We'll just call it the risk factor Pig file. I'll create that, and then from there, we're dropped into kind of a Pig editor, and we're going to go ahead and use this notion called a Pig helper. And we want to, the very first thing we're going to do, I guess I'll just add a comment there. We want to load up, oops, nope, I used the dashes. Want to load the Hive table called geolocation. And in Pig's world, that's not too hard. We have a lot of loader opportunities. So we'll go look under H catalog, and we'll use this kind of help tool, this syntax builder to help us out here. So that particular table we're looking for is, as we said, geolocation. So that line will load up that file for us. And then after we load it, probably what we're going to do is we want to, that has all the events in there. We want to get rid of I guess I want to call them the non-risky behavior. We want to throw that stuff out, behavior. And to do that, it's really kind of a filter by, so we probably have something like that, a filter as functional, filter by. So we want to filter Well, I guess I forgot one thing. We need to assign the output of that load to something. We'll just call it geo. And then we're going to filter geo. That's the thing we care about. And then we're just looking for some kind of condition that we can throw out. So we want where the event itself is not equal to, and if you looked at the query and looked at the data, you'll see that those events that are normally just get indicated that way. So we're also going to get rid of attributes that we don't really need, and create a counter attribute, if that makes an attribute. And what might that look like? That's kind of a for each generate. So again, these are in a second, since I'm use Pig quite a bit, I'll probably stop using that pull down Pig helpers function, but it's definitely something when you're getting started is very helpful to get you going with the syntax. So events, and again, the focus of this demonstration is not necessarily to make you a master of the language, just to show you how we do some things. So I'm gonna get rid of I'm gonna for each on risky events, and then this is this for each generate, as we talked about, is more of a projection concept, and we'll generate for each risky events. We'll generate. I'll just put my little line. We'll keep the driver ID. We'll keep the event itself, and then I'm going to basically I want to kind of put a counter for that one particular record. So occurrence ACCUR ANCE. Sounds good. At that point, I'm going to go ahead and just to speed up, I'll do a little bit of cut and paste as we go. So we're getting rid of the attributes we don't care. It's a real common theme that you see we do in Pig. Another thing we'd want to do is lump all the events, clump them together by the driver IDs themselves, all the events for a particular driver. Then from there, we'll just total up. And this is very, very common in Pig, where what we do is we look at, I don't want to say trivial operations. We look at operations logically, and we let the Pig runtime engine take all this once it's runtime and decide what's the most efficient execution path to pull all this together and get us the answer we want. So sometimes it may look in Pig that we're doing something inefficient, but the reality is we're really just trying to be a good programmer and think about long-term maintainability. And at this point, so there we go, we loaded up, and then we did some more trimming here. We did some calculations. We totaled up the total number of events for each one of those persons. And at this point, we also will go ahead and, just like we did earlier when we loaded the geolocation table from Hive, we're going to load up the driver mileage. This is the one we just created a few minutes ago as a CTAS. And why are we doing that? Well, we're doing that because we want to join those two logical tables or large data sets together. So this is just a quick syntax of how I would join those together based on the driver ID. And then ultimately, I just want to take that join result and spin it. Well, I think I missed the join. I sure did. Apologies. So we loaded it. That was the kind of recalculate it, respin it. And then we want to join it. A very simple statement here. I'm sorry. The join. There we go. Join it that by that. Very straightforward. And then really what we did here is we casted that in such a way, reprojected it in such a way we can store those results back into that Hive table we created earlier via this thing we call hcatalog. So ultimately I'm storing in that final data that we just created. Now to run this thing, we definitely need to add an argument because we're using this thing called hcatalog. So we need to add that property there. And at that point, we should be able to check that as this. Let me do a quick save of the script in case we have a bug. And I will kick it off and pause the recording until it finishes. So I think we're off. And once we got running, we definitely can kind of just trail the logs and details as a result. So again, it just started, so we probably don't have any of that information just yet. But we'll let it get here and get finished up. So it did finish running, but looks like it had an error. So we'll just take a quick look at the logs. And it is calling out maybe on line 9, column 1, we had some problem with our for each double set of quotes. So let's just take a quick look at the script itself. Line 9, column 1, for each risky events. I think all we forgot to do is just assign that to something. So that's easy enough. We'll just call that risky, then riskies. And why that name? It's the name I picked earlier. In fact, I use it just a little bit later. So I'm going to hit save, and we will try to execute that again and run it to completion. So it is off. And of course, what demo would be complete without a couple errors? So looks like, again, it's complaining now. Line 9, column 22, undefined alias, risk events, 922. So we'll just take another quick look. Line 9, column 22, risky events. Fair enough. This is an S. This is without an S. We'll add the S one more time to save it and execute it. And the third time is always the charm, I'm sure. And now that it finished, we're just looking, a bunch of log information where we saw those errors. So I'll collapse that. Usually in our pig world, what's more interesting is the information we have in our results column and etc. And then we can just download that or do something else with that. But if I look back at the script, it actually ended by the fact that we stored those final risk factor results into a Hive table called risk factor. So to validate all goes well, what we need to do is navigate over to Hive again. And in fact, that table, as we saw over earlier, the one we created is called risk factor. There it is. And we'll just make sure there's some data in there real quick. So, just the quick test that we saw earlier. Yep, there's some data. But probably more importantly, we're trying to look for probably the top 5 riskiest drivers. So let's select all from risk factor. Instead of limit 10, why don't we do something like order by the risk factor. That was the name of the column in particular, and then I guess I should have left a limit on there. So if we want the top 5 the riskiest drivers from the most based on that risk factor calculation, we'll kick off this query. And let's see what happens when it finishes the results here in a second. And now that the results are done, we'll navigate down, and here's those top 5. So our risk factor number is basically the lower number is worse than the higher number. So interestingly enough, even between that first and second, this person's twice as risky as the next person, and then from that point it kind of narrows off. So we'd actually have a quick it'd be interesting to see if we did more than 5, maybe 10 or 15, to see do we have a tight batch toward the top, or do we have a pretty even risk factor that's settles down in the 70s or maybe the 80s, 80,000 numbers here. So that really concludes this demonstration. What we could do with this kind of calculation now is to use some rich BI, some visualization tools that you're very familiar with. There's plenty of commercial off-the-shelf solutions. There's plenty of kind of hybrid, open source-ish solutions, as well as some Hadoop-only technologies that sit on top of that. All right, we'll pick it up doing the same risk analysis in another language in the next demonstration. Thank you.